Hi everyone, and welcome to Major Migrations Made Easy. My name is Tim Beek, and I'm a staff software engineer at Moderne, where I work on OpenRewrite. Thank you all for coming to what is the fourth talk of the day to mention OpenRewrite. It sure is good to have a lot of friends here among the fellow speakers. I guess what sets my talk apart is that I brought stickers, so stick around to the end and come find me. Now, even though this is a presentation on migrations, I'm not going to ask you to raise your hand to gouge which version of Java or Spring you're using. And that's because it's not very representative. For starters, you came to this presentation, so there's a bit of bias in that already. And if I do ask you, then some overconfident folks will immediately raise their hand the moment that they got one service to run on Java 17, completely ignoring that they did not pick up any of the new language features yet and that they left the rest of the company behind on Java 8. So instead, we're just going to assume that you're here, you're probably working with something that you want to get rid of. And if you're not confident with that, you're welcome to silently accuse the person next to you of still using Java 8 or JUnit 4, and you'll probably be right. So, before I switched to Moderne, I was a consultant for 5 years, perhaps much like yourselves. I specialized in migration engineering, which is a way of saying I would walk into an organization, familiarize myself with all the old technology that they were still using, and then gradually hack away at lifting everything up to the latest versions. I would frequently find 5 to even 10-year-old versions of Java, JUnit, and Spring, which is not great from a security or even developer experience point of view. Initially, I would migrate these services by hand and then gradually introduce more coarse-grained automation. Because it's boring stuff, right? You have to rename a method here, you have to change a packet there, you have to update some property. You wouldn't want to do this by hand. So imagine my excitement when I discovered OpenRewrite. OpenRewrite promises to make light work of all such migrations. I got so excited about this technology that I started to contribute and even present about OpenRewrite, and eventually quit my job to work on OpenRewrite full-time. So after a nice sabbatical, that brings us here today. And perhaps you face some of the same challenges that I did. At a conference like this, you'll hear all about the upcoming features in Java 21 and new framework releases. But back at work, you might still be stuck using Java 8 and JUnit 4. And migrating all of that by hand can seem daunting if it ever gets priority. I want to show you how easy it can be to perform major migrations. That way you too can adopt the latest language and framework features. And it can be fun to adopt new features such as records and text blocks, but you don't want to adopt these features manually or only on a single project. Instead, we're going to look into automation to make old projects feel like new projects again, rather than a project that's only had its version number changed. That way you can benefit from JVM, language and framework improvements. Here's a brief overview of the types of migrations I'll be talking about. Likely you've already performed some of these migrations in the past, and other migrations are always just around the corner. If you look back over time, there's a near constant stream of worthwhile improvements to pick up. And I like the challenge. I still get excited whenever a new version comes out. I just don't like the repetitive elements that come with upgrading. And if you try to keep up by hand, you will hardly get anything else done, especially as microservices these days mean you're not just upgrading once, but dozens of times. Over the years, we've seen organizations adopt microservices, which tend to look alike. That can be by either consciously using reference templates, or by just copy-pasting from the last service you worked on for any new development. And this can be great for knowledge sharing and reusing shared components, but when a critical issue arises in your technology stack, suddenly everything's on fire. To react quickly, you need a framework that allows you to make broad sweeping changes safely and at scale. Automation may be the only option, especially for large organizations maintaining thousands of services. To show you just how easy it is to migrate a project, I've prepared a small demo. For this demo, we will migrate an old Spring Pet Clinic branch from Spring Boot 2.0 on Java 8 all the way to Spring Boot 3.1 on Java 17. We will look at the commands and changes made in more detail along the way. And so for that, I'm going to switch screens, which is always a risk on Linux. Yep. Horrible resolution, but it gets the job done. So, for this demo, I'm going to take you to a documentation page on OpenRewrite, which is available at docs.openrewrite.org. If you only remember one thing from this presentation, let it be docs.openrewrite.org. There you can find all the information that I'm telling you today, as well as all the recipes that we have available for you to run. And if you get stuck along the way, we have a few different platforms where you can reach out to get help. And so with that, I said we were going to look into a Spring Boot 3 migration. Now you can either browse our catalog to find that Spring Boot 3 migration, which will be under the Java recipes, and then from there go to Spring, or just type Spring Boot 3, and it'll get you there as well. Now an interesting thing with this migration is that we don't really care where you're coming from. Because for this Spring Boot 3.1 migration, we're gonna just find out what you're using right now, and if you still need to upgrade to Spring Boot 3.0, then we'll first take you there. Because there's not a lot of steps to get you to Spring Boot 3.1, but for the Spring Boot 3 migration, there's quite a bit of steps. So even if you're not a Spring user, there's still going to be some changes that will be relevant to your projects as well. Because the developers behind Quarkus and Micronaut use some of the same recipes to get you to Java 17 and Jakarta and other similar changes. So for the Spring Boot 3 migration, you see that we first take you to Spring Boot 2.7, but that should be familiar by now. But we migrate you to Java 17 as well. And we might upgrade you to Jakarta, and there's just a lot of things that you will probably recognize if you've already gone through the migration of the guides. But what we've done here is we've automated all these changes. So if we take you to Java 17 and you're not yet on Java 11, then we first take you there. And you can see how we do that. But one thing that's maybe important to note, which was also in an earlier presentation this morning, is that we also apply some of the optional changes. So if you're going to Java 17, you might in some cases want to adopt things like text blocks. So if you're doing any kind of string concatenation for your queries across multiple lines, it would look better as a text block. So we apply those types of changes as well. And so with that, this is just how you can browse the recipes that we have available. But as I said, we're going to see how these actually run. Now you can run this on your own machine, and for that we have this little usage instruction. If you're using Maven, it's as simple as copying this one command and executing it in the root of your project. Now I've given demos in the past where I do this live on my local machine, but then the output just doesn't look as good. You're going to be seeing a terminal, you're going to see a diff on a command line. It just doesn't look good. So what I'm going to do instead is switch you over to our platform, where we allow you to run these same recipes at scale. So for that, we're going to go to Moderne. We're going to log in, and this is the exact same recipe, but now at app.moderne.io. And you're able to run this against any of the 35,000 open source repositories that we have. And not just this one recipe, but the close to 1,000 recipes that we have available there. So what I'm going to do is I'm going to run this Spring Boot 3 migration against two branches of the Spring Pet Clinic. One branch is the a very old 2.0.0 branch, and the other one is a just the main branch of the Spring Pet Clinic, which is already on Spring Boot 3.1. And I'll tell you why in just a minute. Now, doing a live demo is always a bit exciting for me on the stage, because you never quite know if your colleagues have broken something in the meantime. And to give you a bit of a background, we've spent the last 7 weeks working up to a new Beek 8.0 release, because we had some performance issues before, And we've been working for weeks now, and even some weekends, to get us onto a new version to fix these performance issues. And I can honestly say, after 7 weeks, we've managed to make it worse. So this demo used to run in just a couple seconds, and it now takes 6 minutes. So I'm not going to make you wait for all of that. Instead, we're going to switch to some of the recent recipes that we ran, and I'm going to see the results that are already in there. So sorry about that. Imagine that it's pretty quick, and hopefully by next week it will be quick again. So this one is already failed. Maybe this one works. Yes. It's unavailable for 2.0. That's not good. As I said, we have run these recipes against a main branch, which is already on 3.1. And if I show you the results, then I can tell you a bit why we did that. Now, as I said, we also apply some optional changes, things that might not be necessary in an absolute sense, but will still make your application feel more recent. And I'll go through a couple of examples in the main branch of the Spring Patterning project. One of them, as also pointed out this morning by Martin Lippert, is that we remove the path variable arguments, where they can be deduced from the parameter, the argument that they're applied to. It's not necessary to add these anymore, and it's not been for quite a while. But it's still in the reference implementation of the Spring Patterning project. And there's a couple more of these types of changes. And let me just show you the next bit, where here you have an auto-wired annotation. And this has not been necessary since Spring Boot 2.0. Yet it's still in the 3.1 branch of the Spring Patterning branch. We do more of these changes, and it's all just things that you would otherwise have to apply by hand. It's boring work, it's error prone, and you're likely to forget a couple steps along the way. You can see here that we're introducing a text block, and in here we're adding static imports for AssertJ. All these things that might not be absolutely necessary, but still going to be really nice to see applied to your projects. And if you think this looks good, you can click this one blue button and either commit directly if you're a Spring developer, or start a pull request, which will go out to the Spring Patterning project, and from there can be picked up. And then in my next demo, I won't be able to show these issues anymore. But this is, like I said, applying the changes to a project that's already been migrated to 3.1 by hand. It's more interesting, the changes that you'll see if we apply the same recipes to the 2.0 branch, because in that case, we're gonna see some more interesting changes. So let me try to find a branch that's already completed. I don't think this one's done yet. And unfortunately, some of the older ones are unavailable, which is a bit unfortunate. Like I said, it's a risk of doing a demo. So instead, what I'm going to do is I'm going to show you a different set of recipes that we also run. So in addition to migration recipes, we also have some recipes that will improve your code quality. And we've grouped those together into the common static analysis issue recipe. So let me quickly show you the details there. The common static analysis issues is where we've grouped together a lot of findings that you would probably get from other scanning tools that you apply. So if you're using Sonar Cube or Sonar Cloud, they will give you a report of where you're not in compliance with the enforced code rules. But we thought, well, we have a tool to make code changes. We might as well try to get you compliant with these automations. So if you look through this list, it will probably ring familiar from some of the top 10 Sonar issues that you have in your organization. And we can apply these with ease quite quickly on your projects. And we can run these not just on one project, but we can run them across just a couple hundred or even a couple thousand projects at the same time if you want to. So if I run this, then it will schedule all of the workers in the background to start applying all of these fixes to some, in this case, 158 Netflix and Spring projects. And you see that quite quickly the first results start to come in. Let me zoom out just a bit so you can actually see the table. And you can see that we scan a lot of these files and often find results. And if you actually look over the projects, we pretty much find things we can fix in just every project that you go through. And for all of these fixes, we have a small arithmetic that we do to gather the amount of time we think you would save by running these recipes against your organization. And in the end, this adds up to hours and hours of time saving in just, in this case, 1 minute of running this recipe. And if I let this run for a while, and I'm going to switch to a different tab to show you that, then this is unavailable. In the end, this is going to result in some 200 hours of time savings, which for a couple minutes with a tool is a pretty good result. If you do this on a Monday, if you ask me, then you're free to take the rest of the week off. It's just very easy, very convenient, and you do a lot of these fixes across the board. Now, another type of fixes that we can do is not only find vulnerabilities across your entire organization, but also give you the minimal fix to actually solve these issues. So I'm going to see if this actually wants to run quickly. But what we're able to do here is we're going to cross-reference all your dependencies and your transitive dependencies and their transitive dependencies across your entire organization against the GitHub database of vulnerabilities. And if we find any hits, then we will make the minimal change that we can to actually overwrite this version. And that includes injecting a property if it's a managed Maven dependency with the version defined in a Maven property. And then I'm not sure if this one will show that, but know that, again, you're able in a couple minutes to just do these fixes across your entire organization in a couple minutes, which I think is pretty sweet. If you know that this is possible, you likely don't want to go back to finding these issues by hand or fixing them with just a flood of dependable pull requests. So that's our tooling, how we are able to run these recipes. And what I now want to go back to is show you how we actually develop these recipes and what's behind it. And so for that, we're going to close the demo. Let me see this one. No, didn't work. And I'm going to switch back to joint display. I have to click there, right? There's a delay in the mouse. Yeah, managed. So, let me get the screen back. Come on. All good. So, as you've seen, with OpenRewrite, you can now upgrade between versions of Java and Spring with a single command. You can even migrate between frameworks, such as from JUnit to AssertJ, and even from Java EE to Spring. In this talk, I'll tell you all about OpenRewrite, like how it came about, how it works, and what you can do with it. And finally, we'll briefly look at who's developing these recipes and how to apply them to open source projects. OpenRewrite was started at Netflix, initially to aid in the migration of an internal logging framework to SLF4J. And you can probably imagine that any logging framework is going to be pervasive throughout an organization. To even consider migrating, you'd need perfectly accurate automation, especially when usage is spread across hundreds of services. So they developed a parser to accurately read Java and turn source code into a lossless semantic tree. This model can then be modified to replace the old logging statements with calls to SLF4J. And next, the migrated model is written out as close as possible to the original source code. And this way the applied changes are minimal, leaving surrounding code untouched. And later, the same developers moved on to work on Spinnaker. And while trying to onboard teams and organizations there, they found that teams often struggled with these same outdated libraries and frameworks. To help these teams adopt the latest versions, they applied a different set of transformations through the same lossless semantic tree parser. This allowed them to quickly reduce this technical debt, bringing teams from Spring Boot 1 to 2 and from JUnit 4 to JUnit 5. And the project has since been open sourced, with the company behind it committed to making all recipes available under the Apache license for open source software. The initial focus for OpenRewrite was on Java virtual machine languages and surrounding technologies. There are parsers for Java, Groovy, Kotlin, YAML, and XML. And these in turn unlock support for build tools such as Maven and Gradle, and libraries such as JUnit, AssertJ, and Guava. Ultimately, refactoring entire frameworks and platforms is supported, with recipes available for application frameworks such as Micronaut, Quarkus, and Spring. OpenRewrite is not the only parser capable of understanding and manipulating Java. However, there are 3 benefits you won't get with other implementations. The first is our focus on exact type attribution. By having the exact type available on any tree element, we can be sure to only manipulate exact matches. The other parsers might skip this step to get better performance, but then they lack the ability to match and apply certain changes. The second characteristic that sets OpenRewrite apart is our format preservation. The parser not only takes into account the functional code, but also the surrounding code style and indentation. This allows us to accurately reproduce your source file, regardless of further changes. Any changes made through OpenRewrite will look just like a colleague worked on your code. Then this is a difference as compared to, for instance, Google error-prone's Refaster, which forces you to use their opinionated formatter, which might not be a big deal in some cases, but when you have 20 years worth of commit history, you likely don't want to reformat everything for a couple simple replacements. And finally, our serialization format ensures that you're able to query and refactor your code faster and at scale. And together, these features make OpenRewrite exceptionally good at safe code transformations. And the changes are minimally invasive and guaranteed to work, in part due to our do no harm mentality. By manipulating the full lossless semantic tree, OpenRewrite can far exceed the simple search and replace operations. Now, with the lossless semantic tree built, we need to instruct OpenRewrite what operations you want to apply and where to apply them in your code. And recipes are how you define such a group of search and refactoring operations. Together they accomplish a higher level task, such as framework migration. Recipes can consist of a single standalone operation or be linked together with other recipes. OpenRewrite comes with a large collection of fine-grained recipes out of the box that can be combined for common migration steps. You can think of these as Lego building blocks, ready to be applied with the proper parameters. There are hundreds of these building blocks to, for instance, change types, change methods, change arguments, manipulate properties, and alter dependencies and plugins. Individual recipes are implemented as Java visitors that first match and then modify elements of the lossless semantic tree. There are plenty of examples available, but note that you only need a dedicated Java visitors when none of the existing recipes can already achieve your goals. Typically, you can get very far only combining, configuring, and applying existing recipes through a YAML description file. Modules then group together these fine-grained recipes into more coarse-grained application-specific recipes. There are modules, for example, for logging frameworks, for testing frameworks, and for application frameworks such as Spring. Think of these as Lego sets with build plans for common migrations and fixes ready to be used. In my opinion, the lossless semantic tree, combined with the large collection of open source recipes, is what sets OpenRewrite apart from other similar tools, such as the Google error-prone Refaster. Now I want to show you how migration recipes are configured in OpenRewrite. Let's briefly have a look at migration from JUnit 4 to JUnit 5. I want you to imagine what steps would be needed for such a migration. You likely know a couple of these steps already. Among others, you would have to update the test annotations. But you'd also have to update the assertions and sometimes their argument order. You'd have to update all imports, you'd have to update any test rules, and that's just getting started. Notice how each step is reflected as a separate recipe in this YAML configuration file. Some refer to and configure generic steps, such as the change type recipe. Others are implemented as an imperative step, a dedicated Java visitor that changes the lossless semantic tree. All these steps combine to achieve a complete JUnit 5 migration. And this is a common pattern with OpenRewrite. Large migrations are broken up into small reusable steps. When we run this recipe, we get predictable results. Our imports are converted as we would expect, and our Mockito runner is converted into using the extension. Lifecycle annotations, such as that before, are correctly replaced. But interestingly, we can see how OpenRewrite shines through when it comes to converting expected exceptions. Having the full power of a lossless semantic tree, combined with a Java visitor, allows us to adopt assert throws. This would not be possible with just any regular expression approach. And it's just a small sample of the types of changes that are possible with OpenRewrite. Running migration recipes, as you quickly saw in the demo, is fairly straightforward. First, you apply the build tool plugin for OpenRewrite. Now this sample uses Maven, but Gradle works just as well, and we're working on support for Bazel as well. Then, depending on the changes you want to make, you add a dependency on your respective OpenRewrite module. And lastly, you run the OpenRewrite plugin with the migration recipe that you want to execute. The command seen here will take a Spring Boot application and upgrade it to the latest version, and it works all the way back to Spring Boot 1.5. It will update dependencies, properties, and deprecations from any older versions, and it includes the JUnit 5 migration that we saw before, as well as any Spring-specific test constructs. So now that we've seen how OpenRewrite works, let's have a look at what else you can do with it. Obviously, by now we've seen that it is well suited to migrations. You've mostly seen migrations from one version to another, but you can also migrate from one framework to another. If you want to switch from Log4j to SLF4j, you can. And the same thing from switching from JUnit to AssertJ. And even larger migrations are in active development. Another application is, as I showed you, fixing static analysis findings. We support a large collection of Checkstyle, Sonar and security findings to reduce your technical debt in just a couple minutes. And finally, there's a whole class of recipes to enforce a certain code style. And rather than merely apply a formatter, these style recipes go a step further to actually change your code. And this ensures your code style reads consistently from project to project. And in addition to what's already available, it's fairly easy to write custom recipes specific to your project. So now that we've seen how it works and what it can do, let's briefly look ahead at what is still to come. As you've seen, OpenRewrite has dedicated parsers for multiple languages already. But as you can imagine, we have some catching up to do still. We are further refining our parsers for both Java 21 and Kotlin. Note that you're perfectly able to run on Java 17+, but you cannot yet migrate to some of the new language features. The interesting thing about Kotlin is that our Java migration recipes will also just work, even though the languages look quite different. And we're testing this now with the developers behind the popular Arrow framework for Kotlin to migrate people to the latest version of their framework. We're also looking to make it even easier to define migration recipes by using the approach popularized in error-prone's Refaster. And while this won't be able to cover all cases, it is convenient when it can. We're also working on a CLI to make it even easier to run these recipes without changing the build file. And using this to integrate with, for instance, GitHub Actions and GitLab CI for feedback on your pull requests. And we're also branching out into new language families such as Python and TypeScript. All these features are in active development. It's not yet clear when you can use some of this, but it's interesting developments nonetheless. Now I want to call out the Refaster templates especially here, as it will make recipe development a whole lot easier. As you can see here, we define a before template of the pattern that we want to replace as an annotated method. Then secondly, we define an after template of the code pattern that we want to see instead. And these patterns are then matched across your code base and replaced with these. We like this approach so much that we didn't want to just copy it. Instead, we're going to use exactly these annotations. And that also allows us to leverage the work of others, such as at Picnic, where they've defined in open source their Refaster templates. Our users then get the benefit of applying Refaster recipes at scale without the Google Java format enforced by JAVAPRO. And if you need more than JAVAPRO can support, we allow you to gradually switch to OpenRewrite recipes. Now, as a last subject, I want to tell you a bit more about the company behind OpenRewrite. As I said before, Moderne has committed to making all recipes available open source. You can run OpenRewrite on your own machine against any project that you'd like, including private code. It will work, but it won't be quick, and it will only update one project at a time. With Moderne, our focus is on applying recipes at scale. Through Moderne, our clients can discover code patterns across their entire organization and target these for transformation. And even if you're not a paying customer, you can still use the web interface to browse available recipes and even apply them to open source projects, as you've seen me do in the demo. This can be a great way to start contributing back to open source software. And if you find that any migration steps are missing, then OpenRewrite itself is very accepting of new contributions. The community plays a large role in the development of new recipes, and I'm glad to say we have some 5 contributors in the room today. Now, as you could probably tell from my email address, we're not exactly a big company, but we're pretty well connected into the broader Java community. Through collaborations, other companies contribute recipes for their frameworks. And these ensure that their users are able to migrate easily and timely with new releases. And if you maintain or merely enjoy a particular library or framework, you can help all other users by providing migration recipes. And this is something that I've been doing on the weekends as well for Apache Maven. So Apache Maven has a really rich history. It's been going for some 15 years by now. And I'm sad to say that the code base starts to show that as well. So they've, over time, have developed some patterns that they are not as happy with right now. Let me try to bring that up. So they, for instance, in this one, they have across their code base some 4 to 5 different implementations of a string utilities class, which altogether adds some 2 megabytes to the entire Maven runtime, which isn't great. Especially if you then start to look into the details and find that it's mostly checking if a string is empty or it's not empty, which is not really worth 2 megabytes of dependencies. So what we're doing as part of this ticket is using the tools that you saw me use in the demo, as well as some custom recipes, to replace all of these stupid little string utilities calls with just regular calls to the JDK. So checking if a string is empty is now just gonna be is null or is empty. And it's really silly stuff, but it's just with these tools, it's suddenly fun to apply this broadly across the entire code base. So they have some 90 repositories, and I've already opened some 50 pull requests just for these simple replacements. And if you look at how these recipes are implemented, then it's... I'm gonna switch the way my screen works because this is not working for me. Mirror, apply. So in this case, we're just looking at to replace the string utilities is empty with is not empty. And on any recipe that we have, you can go to GitHub to immediately see how is this implemented. And in this case, it's fairly easy. You have to squint a bit. I'm not yet using the Refaster approach, which I could have used here. But we're checking to see if we're using and is empty or is not empty. And if we do, we then replace it with a lambda, which I've defined here. So is the string null, or is it empty, or is it not null and not empty? And it's silly stuff, but it does help if you're able to use this to replace some thousand of these method calls just with ease in a couple minutes. And if you're wondering, well, this looks like a Java program, are you testing that in any way? Then yes, of course, we have unit tests just to verify that we apply this everywhere there it's applicable. And also we verify that we don't do this where we can't be certain. So if the argument to an isEmpty method is actually a method invocation, then you can't be sure that invoking it twice will be safe to do. So we verify that we're not making changes in such a case. And then again, as I said, we have some more of these recipes that we are replacing. This time we are using the Refaster templates. But it's just, if you start to run this at scale, it's quite easy to see the benefits. How you can suddenly maintain something that you would otherwise not consider doing. And I've been quite lucky that I've had one person on the team of Apache Maven contributors who kindly and foolishly agreed to review all of these small little pull requests that I'm sending his way. That's the positive aspect of it. I've also had one person ask me if I could open up a Jira ticket for every pull request that I open. And I was quite pleased that I was able to push back on that, because if you start to do these changes in bulk, you kind of want to check if your processes are actually aligned with the changes that you want to do. Because 50 Jira tickets for just one small change is not going to cut it. And so with that, we are getting near the end of my presentation. So before I send you on your way, I want to recommend a few resources where you can learn more. The first link is just the docs.openrewrite.org, which I recommended at the start, where you can learn everything about the recipes that are available, how to apply them to your projects, and how to develop your own. And if you get stuck on in any way, then you can reach out via our public Slack, which I really recommend if you start to do your own recipe development. If you want to follow along to what we're doing or even contribute, then all our development is up on GitHub, on github.com/openrewrite. And if you want to apply these recipes at scale on public projects, then you can go to app.moderne.io and do everything that you saw me do in the demo. You could even start to help out in the Apache Maven cleanup of the Commons Lang 3 if you want. I do it on the weekend. It's fun, it's quick, but yeah, you're welcome to have your own hobbies. Now, together with this presentation, I quite a while ago also wrote a blog post, which takes you through some of the same steps. Now, it's about a year old by now, so it migrates you from Spring Boot 1.5 on Java 8 to Spring Boot 2.7 on Java 17. And it takes you through all of the same changes that I've talked you through here, but it does them one at a time. So you can see the changes that are made at every step, and you can see how they would apply to your projects as well. If you want to start applying recipes to your own projects, I recommend that you start with the testing framework migrations that we have. They're an easy way to gain confidence in the tool, and because they're tests, they're pretty well covered, and you can see if they will actually work. And with that, I'd like to thank you all for your attention. We have a couple minutes for questions, and since I keep forgetting, I do have stickers, so come find me if you want a sticker as well. Are there any questions? It's an interesting question. I didn't work it into the presentation yet, but you have to consider, like, a lot of our customers are large banks, large financial institutions, and they like predictability. If I give you a tool and it will give you a different result today versus tomorrow, are you going to trust that tool fully to always do the correct thing? I don't think so. Like, I want predictable results. So we're not using AI to make the code changes. We have a recipe or rule-based system, but we are using AI to make these recipes and these rules. So we can actually validate that they actually work with tests and everything that you've seen us do, while still getting some of these benefits. But if you ask me, I don't want AI to rewrite my code. I want something that I can actually trust and verify. But you're welcome to throw it into something and see what it does. And see what it does tomorrow. Does that answer your question?
Yes, thank you.
Cheers. Any others? Yeah?
By our migrations, if it's compiled with Java 17, we were finished.
Yep.
We never use text blocks.
Yep.
Can I migrate Java 17 into Java 17?
Absolutely. Yep. So that's one of the things that we do recommend. Even it doesn't really matter where you're coming from. We will just find any optional steps we can still apply to your projects and run those still. So you can even, as a continuous step, say, upgrade me to the latest version, whatever recipe that's going to be tomorrow, and find any place that I've not yet applied these changes. And that's also another reason why we're not using AI to make these code changes, because AI has been trained on old code. It's going to insert old code patterns. Your colleagues are going to use Copilot to insert code patterns that you might not want. So even if you clean it up once today, maybe by next week you still want to run some of these improvements and get those benefits. So we do recommend that you not migrate once, but you run it continuously. So you keep those benefits, even if your colleagues insert old patterns that you want to get rid of. So yes, we support migrating Java 17 to Java 17. If you did it by hand, we'll figure it out. If you insert something old, we'll still fix it. So yeah. Yeah, go ahead. Yes, absolutely. So I think this is the slide does it better than I do. But you can run OpenRewrite on your own machine, but it won't be quick. So to do the things that we do, we have to build up a detailed model of your code. And that's the most time-consuming step. So if you have a large monorepo, that can take half an hour, maybe even an hour or more. And it won't even work for very large projects. The reason we went to OpenRewrite 8, which is the release that we're just now edging up against, is because the guys from Drills showed up and they want to run OpenRewrite against a 200 multi-module Maven project, and we didn't quite support that. So we likely support that better now, but with the platform we absolutely can support that, because we build up that model ahead of time, instead of spending hours, maybe even days on your machine building up that model, then running a change once and throwing the model away again. So that the benefit of the platform is the ease with which, the speed with which you can run these recipes, the ease with which you can then make pull requests, and to run things repeatedly. Like I said, if you want to go to Java 17 and make all those changes, and next week do another cleanup of what might have been inserted since, the platform really makes that easy. Whereas if you run it on your own machine, you're gonna be waiting around for a long time. We had a guy he's now a customer, but he used to, in our Slack, give out like movie recommendations that he was watching while running OpenRewrite on a large monorepo. Which, like I said, it's not intentionally slow, but it does take a while to do it right. Any other questions? Two more? Yeah?
So the OpenRewrite is something like findback or Checkstyle, or is it just an addition or
So
replacement or something?
it's a fully separate tool, and what spot bugs and find bugs do for you is they find those bugs, whereas we try to not only find them but also fix them for you. So they might give you a recommendation, we give you a patch, or a new commit. So I think that's better.
So I don't need to find bug detect, just go to OpenRewrite, or I need the knowledge from
Um,
Checkstyle to find the receipts in OpenRewrite.
So what you would likely find is that the difference in coverage in what other tools cover versus the recipes that we have. Some of those tools might find something that's not directly actionable or is not immediately able to be converted in an automatic way. So what we recommend is you probably run those tools already. Look at what's the top 10 of what they give you and see how that aligns with the recipes that we have. And we can probably fix 8 out of 10 immediately, because it's not the first time that we see those issues. We've been hearing that from customers for quite a while. So take the top 10 of the issues that you currently have, match that with OpenRewrite, and see what you can fix. And then look at the next one. Cheers. That as well. Yep. So what I alluded to in the presentation is the do no harm mentality. So what that means is that we only make changes when we can be absolutely sure that we can do so safely. Because we're not giving you a report for you to go through, we're actually making a code change. So we're not gonna ask you to do a rigorous code review on the code changes that we make. No, we only make those changes when we are certain. So kind of you to point out that yes, we don't have the false positive issue. Yeah, sure.
Thinking of larger projects where you apply larger migrations, for example, Spring 2 to 3. What were the limitations that you discovered where a recipe didn't quite solve the problem, where still manual interaction was needed to get the service running?
So we have a couple recipes, but we don't have perfect coverage of every aspect of Spring. So if you use some queuing mechanism that we haven't looked at before, then we likely don't have coverage there. But we can, if you go through the changelog, you can quite easily, with some YAML configuration, likely do part of this migration already. So there's limitations in what we already cover based on what we've seen. And there's also cases, for instance, with Spring Security, where we know we're not able to fully migrate some situations. Well, what we do in that case is we insert a comment exactly at the place where you should have a look. We recognize that there's work to do here. We also know that we can't do that, but we're pointing it out to you to actually fix it there. So that's another approach that we have. I want to be mindful of the time. I think we have 2 minutes, but yeah, sure.
These cases where you add comments, you're not able to implement the change yourself. How confident can we be that whatever is migrated still works as it did before, and there are no surprises? What's the success rate? The average success rate of migrating an average project
Mhm.
that does not have any magic implemented or any special case or something. It's a regular Spring Boot application, for instance. What's like the success rate where I can be confident
Mhm.
migration is still going to work?
So I don't have any numbers there, but we do have customers with quite literally hundreds of services or even thousands of services that they're migrating in this manner. And they are quite pleased with the time savings that they have, as long as you have a test suite which will actually uncover any issues that might arise. But the compiler will probably pick up things where it's imperfect, but we're less likely to make code that won't compile. And otherwise you probably have a test suite which you will also pick out some of these failures. So that combined with the do no harm mentality, I'd say we're pretty confident in the changes that we make are going to work. You might lack some coverage, but yeah, then in that case, you're gonna have to make those changes by hand anyway, or come to us and contribute an issue or a pull request to fix that at scale. Cheers. Yeah. Yes, absolutely. So like I said, with what we do in terms of language mapping, I'm over time, is we map both the Java, Kotlin, and Groovy all to the same model. So if we've defined that you need to replace a package or rename a method, and that's part of the Spring migration, then that will work just as well for Java, for Groovy, and for Kotlin. So we don't have to start new every time we have a new language. No, we actually map those elements, such that we're able to reuse all of that. So I want to be mindful of people that want to leave. So thank you again all for also for the nice questions, and then yeah, hope to see you around. Cheers.